Hello everyone, welcome back to my YouTube channel. My name is Nandini and I scored 632 out of 720 in NEET 2024 examination, and currently I'm preparing for NEET 2025 because I did not get a government MBBS seat. So as you all must be seeing here that I have the questions of Allen Achiever test series. So it was held today on 22nd of December 2024, and I am here with the solution for the first 15 questions of physics portion. I'll be making videos for physics and chemistry and biology if you all will ask for it. And do let me know that how did you find the video, and did you all understand what I was trying to tell you all, because I'll just be briefing the questions and telling the solutions of the questions with a brief description about each question. So without any further wastage of our time, let's get into the video, because I, being an aspirant, personally knows that how much importance the solution for each question matters to us. And many a times we tend to skip the question just by seeing the answers or remembering the answer, but that is not the proper way, you all also know. So here I'll be discussing the questions in a quick manner so that you can have an idea of each and every question, and that will really help you a lot to boost your score. And you'll get, and those who are not, who haven't joined the series, they'll get an idea of the question, that how the questions come and what is the approach to solve. It's better to get diverse idea about the various questions. Okay, so the chapters include were electrostats, capacitor, and current electricity. So in this video I'll be taking 15 questions, and my further videos will be based on your response, that whether did you like or not. So without any further wastage, let's get into the video. First question, very easy one. You can read the question by pausing the video. I'll put up the solution here. So here it is asking that on each sphere after the contact, true statement you have to answer. Okay, I'll also be telling that how did I attempt the paper. So here, if you know that there are two charges, then the final charge on each sphere will be q1 plus q2 upon 2. So here it is minus 9 plus 5 divided by 2, which comes out to be minus 4 by 2 microcoulomb. Now this is minus 2 microcoulomb, and we know that q equals to ne, so you'll equate it, and because it's minus, so it is in excess. Deficit wala options to get cancelled, excess wala options remain, and if you'll put up this formula, you'll get the number of electrons. Okay, now moving on to the second question, unit of a medium, dielectric constant of a medium. So because this medium word is emphasized here, we need to remember that it is asking for the relative permittivity. Okay, because medium is there, so we know that relative is that of the medium with respect to the space. Okay, so that is the dielectric constant of a medium. That will be unitless because it is a relative quantity, and relative quantities are unitless, so that will be the answer. Now coming to the third, find out the correct. See, I always used to mark, means I always mark what is asked in the question. Here correct is asked, so I'll mark it. Now moving ahead, positive charge P is a position of stable equilibrium for displacement along AB. Here two positive charges are kept, okay, and a positive test charge is being kept here, and if you move it over here towards this side, then this plus q and plus q will repel. Okay, and if you move it to this side, then again this plus q and plus q will repel. So which means that if you are moving it from P, then the plus q is letting it to come back to the same position, which means that it is a position of stable equilibrium because the test charge is coming back to its original position after being displaced. For negative test charge, P is a position of unstable equilibrium. Obviously, if you will put up a negative charge, then plus and minus will attract. Plus and minus will also attract. But if you'll move it towards here, then this attraction will be larger and greater than this one. So it will shift away to this direction. And if you move it to this direction, then it will shift towards this charge. So it is a position of unstable equilibrium. Now these two have been gotten correct. So we'll mark all of the above. Why to read also, but you can read it, but there is no need. In the exam we have to solve a lot of questions, so very quickly we need to be answering the questions. So if we got these two correct, then we'll go with all of the above. Now a charge q is placed at the center of the square. Okay, what is it asking? E2, then E1 by E2. It's not asking E2 by E1. Okay, it's not asking this, it's asking E1 by E2. So very quickly we'll calculate. E1 will be electric field intensity is kq by r square, right? Now if we'll make a square and here it is kept and it's asking over here, so this is root 2r, so this will be root 2r upon 2, so this can cancel, this will r by root 2. So E1 will be kq by r square and over here it will be 2, and E2 will be kq by, see, it's asking over here this at this position, so this is L by 2, right? R by 2, so r square by 4. Now if we'll do E1 by E2, not E2 by E1, so it will come as kq2 upon r square, and here kq4 r square, so it will come as 1:2. This will be, I'm trying to be really swift, that not much of your time is getting wasted over here. Okay, so I'm trying to keep it very crisp, and I hope that you are all getting the answers. Now this fifth question, ring is given, electric field at center is asked, and the charge densities are given. Okay, so 2 lambda, this is positive, so it will be away, and for negative it will be towards, so this way, and 3 lambda positive away, and for negative it will be towards, so this way. And then when you will calculate, the electric field will come this way. You can also eliminate the option, because I cap to can never happen, because the electric field is in the negative y direction. And when you calculate, because you know that 2k lambda upon r is the electric field when the charge density is lambda and the distance is r, so when you'll put up the values accordingly, like 2k and lambda ke jagah pe 3 lambda upon r, so you'll put up the values, you will get this option. Fine. Now moving on to the next question 6. 3 charges are shown. Okay, flux is asked through the surface S2. Okay, S2 flux, we all know phi is equals to q enclosed upon epsilon naught, and we know ki k is equals to 1 by 4 pi epsilon naught. Now this epsilon naught will be 1 by 4 pi k. Okay, and 1 upon epsilon naught will be 4 pi k is equals to 1 upon epsilon naught. So we'll put up the value over here. So phi comes as q enclosed, which is q2 plus q3. q2 is 2, q3 is minus 3, so it will become minus 1 microcoulomb, and 1 by epsilon naught value is given as 4 pi k, so into 4 pi into k is 9 into 10 to the power 9. Okay, microcoulomb will be converted into coulomb, answer will be minus 36 pi into 10 to the power 3. Fine. Okay, now electric field at a distance r from the surface of a uniformly charged non-conducting sphere. Uniformly charged non-conducting sphere, okay, rho r upon 3 epsilon naught. This is from the center, and radius r is this much. Okay, from the surface. Okay, so this is the center, this is the surface. So electric field at distance r from the surface, which means ki from the center it is 2r, and non-conducting is this much. Electric field at a distance r by 2 from the center of the sphere. Okay, here it is asked r by 2. So when you will put up the formula, you will get, see, I also have this one with me, but it becomes easy for you people to understand. See, here it is given kq upon r square. R will put 2r ka square, because we know that the distance is 2r from the center. So matlab here to bahar mein outside it will be kq upon 2r whole square, which is 4r square. Okay, and the value is given as 20, and inside the formula is kqx divided by r cube. X will be r by 2. Once you put up the formula, you will get as 40 volt per meter. Fine. Moving to the next, variation in electric field for uniformly charged sphere. Again the same, rho r by 3 epsilon naught or kqx divided by r cube is given. Then you need to find, see, here and here electric field is same. 2r comes out of the sphere, and r equals to x is inside the sphere, because here it is on the surface. So I think that you are getting what I'm trying to say. So again, you'll put kq divided by 2r whole square, which is 4r square, is equals to kqx divided by r cube. So you will get it as r by 4. X key value you will get. Okay. So again, uniform electric field in the x direction. I hope that the video's length is not that much. Uniform direction. In the x direction, charges of 0.2 coulomb through a distance of 2 meter, making angle 60 degree with the x-axis. X-axis, the angle is 60 degree, is this much. So we know that work done is equals to force into displacement. Force is q into e into displacement. Q is 0.2. E value of e is needed to be found out, and displacement is 2 and work done is 4. So you'll, and then f dot s, which means fs cos theta, so cos 60, that is 1 by 2. You'll get the answer. Fine. Moving to the next one. Two negative charges, each of these are okay. Potential energy u1 are mutually interchanged. The potential becomes u2, then u1 by u2. Okay, so for that, here already the solution is being available, so you can just check it out over here. First of all, what they have done is kq square. Okay, so this kq, so for that kq square by 2r, because it's kq1 q2 by r, so the distance is 2r. Kq square minus becomes plus, and then for these two, and then for this two, so they have combinedly written it as minus 2 kq square upon r, because these two are two different systems, right? And the third one is that plus wala system. u1 comes out to be this much. u2, how we'll calculate, we'll take these two, and then these two, and this comes out to be this. When you take the ratio, it is 3:1. Okay, so this is also done. Now next, moving to the next question, number 11. Again, statement wise question. Choose the correct statement. I always encircle it, whatever is being asked, and then accordingly, when you read the points, you'll get the answer as third option. Okay, now moving on to the next question, number 12. You need not read all this thing, it's very time taking, so it's not required to read this thing. Just match the options as fast as possible. See, in the first column itself, 1 2 3 4, which means if you get this right, you will get the whole option right. Okay, so you know that electric field lines direction is always from the higher potential to the lower potential. So here it will be lower potential, it will be higher potential, and this matches to this one. So P4. So accordingly, only one option is matching. So you'll get it. This, I think, is from NCERT, statement wise question. You will need to remember this. That's the only thing. So you'll keep it in mind. Okay. Now moving on to the next question, number 14. Specific resistance means resistivity. You all must be aware of that. Must be. And rho, volume is given, resistance is given, length of the wire. So we know that R is equals to rho L upon A. We'll multiply L with length, so it becomes rho L square upon volume, right? Resistance. So we'll put the values. Resistance is given as 3, specific resistance is rho, L ka square, so we need to find, and volume is given as 3 meter cube. Now, so it becomes as 339 by rho is equals to L square. We'll take the root. This comes as 3 upon under root rho. Fine. Now, resistance of a wire is 20 ohm. It is bent in the shape of a square. Okay. Across is diagonal. Okay. So the resistance is being asked across is diagonal. So I have solved it over here also. So like this is the diagonal thing. Okay. Okay. So these are in series. So x and x becomes 2x. Okay, if we'll take the resistance of one of the portion as x, then it becomes 2x, and then this also becomes 2x, and 2x and 2x are in parallel, so which become x, and x will be what? We'll find it out. R is equals to rho L upon A, right? So resistance of a wire is 20 ohm. Okay, it is bent in the shape of a square. So L will be here. Originally it was L, but now it will become L by 4. Right, so R dash becomes rho L by 4A. Okay, R double dash, what will it become? It's asking across the diameter. So here and here. So this will be R. Suppose this will be r this will be r, and this will be r, so these are parallel, so this becomes r upon 2. And what will be the value of r? So we'll find out, as r double dash is equals to rho l dash. We'll take this length upon a, and what will be this l dash? So 2 pi r constitutes to l, which means pi r becomes l upon 2. We'll put it over here, rho into l upon 2 into a. This becomes r double dash, and this we'll put here, so it becomes r double triple dash rho l upon 4a, because we need to divide it by 2. And now triple dash will become rho l upon 4a. We'll take the ratio, it will come out as 1:1. Okay, so I tried to keep the video as short as possible, because I know that our time is very precious, so we cannot afford to lose it or waste it anyhow. So I hope that I was able to make you understand the questions and solutions. And if you find this video helpful, then please do like my video. It really motivates me to make further videos, and whatever else thing you want me to come up with regarding NEET, so do let me know in the comments. Till then, keep hustling, keep working hard, and yeah, thank you.